Hi, I'm Craig Calvin with Bentley's technical support team. Are you interested in performing net positive suction head calculations? The Connect Edition Update 1 release of WaterGEMS and WaterCAD introduces the ability to analyze net positive suction head to identify and avoid cavitation that could damage pumps. Cavitation occurs in a fluid when the absolute pressure drops below the vapor pressure of the fluid, resulting in the formation and collapse of small vapor pockets. The most common place where this occurs in water and wastewater systems is at the suction side of the pump. The net positive suction head required is the head needed to prevent cavitation at different flows and is provided by the pump manufacturer. The net positive suction head available is the margin of actual available pressure head over vapor pressure at the suction side of the pump. This is calculated based on the equation shown. With these two values calculated at each time step, I can determine the risk of cavitation damage occurring. I opened a sample model to demonstrate how this new feature works. First, I need to enter a curve of net positive suction head required, which is the head needed to prevent cavitation. To do this, I'll open the Pump Definitions dialog and select the NPSH Required tab. I'll check Define NPSH Required Curve for Pump Cavitation Check to be able to enter the data and to have the engine consider NPSH when computing. I'll enter the flow versus head data that was provided in the pump manufacturer's specifications. A multiplier can be entered in the field NPSH Required Warning Safety Factor to apply a safety factor above that provided in the manufacturer's curve. I'll leave this set to 1. Now, I'll compute the model. The User Notifications dialog indicates that there are times during the simulation that the required NPSH is not met. Double-clicking on one of the messages will select the pump that the message is referring to and zoom to it in the drawing pane. The Properties dialog shows the pump results, NPSH available, NPSH required, if the pump is failing to meet the required NPSH at the current time step, and it also shows if the pump fails to meet the required NPSH at any time during the simulation. I'll graph the required and available NPSH as well as the flow to understand the conditions under which cavitation can occur. Now I can consider different options to correct this, such as specifying a different pump, lowering the pump elevation, minimizing the head loss in the suction line, or if there was a tank on the suction side of the pump, I could raise its elevation. As you can see, this new feature can avoid costly damage to pumps due to cavitation. Information on net positive suction head and much more can be found in the Hydraulics and Hydrology section of Bentley Communities. Thank you for your time.